Hi, this is Saurabh, and I'm going to show you how Bytebell spec layer reduces the cost of AI by 90% while adding accuracy on top of SOTA models. So here there are two windows, as you can see. We are trying it. The task in hand, which both should complete, is one Claude code with Fable 5, and this is open code with MiniMax M3 with an access to our Bytebell MCP running at localhost 3100. And this MCP has already analyzed the SWE-bench Pro dataset repository, which is Internet Archive Open Library. This is the second commit. 4. I guess it starts with 4. This one, yeah, 4099. So we have already dumped the code for this commit hash for this repository in SWE-bench Pro onto our spec layer, which analyzed it, stores the specs in a database, and then those specs are being fetched by this open code with M3 through the MCP protocol. Allow always confirm, and this is being run without the help of MCP. And how it does is basically clone the repo at this commit hash in a temporary directory, and then brute forcing all the files required to make the patch that can easily pass the test cases. So let's see, this Fable model is basically $60 per million input output tokens, and MiniMax M3 is not more than $1.5 per million input output tokens. So this is basically trying to make a script that bridges the gap between streamable HTTP and the HTTP protocol, so that this can fetch all the MCP tools and run them. Again, it's stuck at, I guess. So the good thing about open code is it already prepared a plan and now it's executing it. First of all, it's not even able to set up the MCP connection. The cost stands at $0.06. Now it has established the connection. This is our internal UID for open library, and the other one is tuta. Now let's see. Yes. Locate the fix using Bytebell MCP. Now it will make a series of calls on our MCP server to collect all the relevant data. So this is the question 4 in the series of we using Bytebell MCP to find out the patches required to solve SWE-bench Pro dataset tasks. Again, it made a call to our and the good thing about our MCP layer, spec layer, is it can analyze all the commits of a single repository at all the branches. It doesn't mess up the code. See, it is making calls to the local MCP server. I guess this step should happen before this step, because you cannot find the code snippets without reading the source code, because you wouldn't know what to solve. Anyways, let's see. So this doesn't, the plan is correct which it actually follows, but it doesn't always do that. It actually shows the step as yellow, the step that is being executed. And they were all yellow. Sometimes it gets stuck in at this step. I don't know why. I guess it's because lot of context it's being pushed in a single API call. After this, I'll try to run without the MCP layer. Let's see what happens then. This is actually completed. I don't know why this is a strange behavior with Fable. It doesn't show the tests that are being run against what. It just shows that all tests are passed and it shows the cost. And the cost is, I don't know what, it will show it here because it's written in their prompt. I think it's checking for the Python path which can be used to run the scripts. It actually ran failed to pass 111, costed $8.25. And let's see, right? Oh, nice. So this is exactly writing the file, open library, then the model name, and then the instance ID. Now it's completed. I'm still waiting for this. This is done. What? No, you are not allowed to do a search. Please continue. Sometimes get stuck with one API call waiting for the response, and open router doesn't even close the connection, it just hangs. Let's wait for it. See, it's $8.25 because 1 hour cache writes dominates this figure. If it wouldn't be cached, then it will automatically goes to $30. $30 for a single query, for a single task on SWE-bench Pro. See, this is how costly the AI is. This is again searching with the help of MCP. I don't know what it is doing right now. It's checking the git logs. The existing, okay, they both use the same narrative. The existing checkout has the ARM-V patch applied. I need to revert to base, then produce my own ARM-V patch independently using the Bytebell MCP analysis. Let's see. So this made the patch and didn't delete it, and now it has to revert back to apply its own patch. The good thing is it's not checking the patch by this. Let me check. This is doing something and I don't know why. What? Tencent high. Tencent doesn't even work. Now it's writing the patch. Now see it. You can see the patch that it applies. It doesn't show anything. Now it's validating the patch. See, it should have shifted here, but it didn't. Pass. This is really great. And the cost is $0.22. And this costed us $8.25. 4 times, I don't know, it's more than 95-96% savings. Thank you. And now it's writing the file.